All right, welcome back. So I guess I must have erased a video or something, because just one of the videos isn't there. I have to remake it now. So if that ever happens, just drop me an email and let me know, and I'll make the video that's supposed to be here. So this is going to be 9.2 video 2. Okay. So first problem has this is number 58. I do have it in the PDF notes already. I just must have deleted the video that I made for it. Okay, so we have AN equals 85, and our sequence is going to be, or is, -5, -3, -1. Okay, and we're asked to find n. So we need to find the n that has the term 85, that goes with the term 85. Okay, so the first thing we're going to do is we're going to find our formula for a sub n. Okay, so a sub n, remember, is a sub 1 plus d times n minus 1. That's our formula for finding when we have an arithmetic sequence. We know this is arithmetic because it's going to go up by 2. So our d is 2. And our a sub 1 is -5. So a sub n is -5 plus 2 times n minus 1. Okay, so that's going to leave us with -5. Oops, sorry. So the -5 and the -2 are going to combine to give us -7 plus 2n. Okay, so that's our a sub n. Okay, so now we got to check, when do we get 85? -7 plus 2n equals 85. That's what we have to solve. Adding 7 to both sides, we get 2n equals 92. And then dividing by 2, we get n equals 46. Okay? The next problem, number 42. I don't know why I did them out of order, but I did. Okay. The next problem is we're going to take and find the summation. 5 plus 10 plus 15 all the way up to 200. Okay, so now that's going to use that little trick, or the Gauss sum that I introduced at the end of 9.1, okay, which says that 1 plus 2 plus 3 all the way up to n equals n times n plus 1 over 2. Okay, so now what we're going to do, we're going to factor out the common factor of 5 here. Okay, if we factor out a 5, we're going to get 5 times 1 plus 2 plus 3 all the way up to 200 divided by 5 is 40. Okay, so now the sum from 1 to 40 we can find using this little trick here. Okay, so we get 5 times 40 times 41 divided by 2. Okay, this is for, if we're looking at this sum, n equals 40. Okay, so that's going to give us, let me get my calculator out here. 5 times 40 times 41 divided by 2 is 4,100. Okay. All right, next problem is very similar. It's 44. Okay, I think that's all the problems that yep. So 44 I'm going to take, and I'm going to write this as it's 4 plus 7 plus 10 all the way up to 301. Okay, so now this one's a little bit different because it's not as clearly the same problem as the one we just did, but it's still pretty much the same problem. Okay, first thing we're going to do, we're going to have to find the form of the sequence. Okay, so here our D equals 3, our A sub 1 equals 4, so our A sub n equals 4 plus 3 times n minus 1. Okay, so we could write that as 1 plus 3n. Okay, so we got our form of our sequence. Now we have to think which one is going to give us 301. So, form of sequence. That's the first thing we have to do. The second thing we have to do is like that first problem we did, where we found which n is going to give us, in that case, 85. In this case, 301. So we have to solve 1 plus 3n equals 301, or 300 equals 3n. So 100 equals n. Okay, so here we're finding the end of the sequence, of the series, sorry. Make things just a little bit smaller. Not much. Just enough to fit the end of the problem on there. Okay, and now we're going to find this sum. So 4 plus 7 plus 10 all the way up to 301 equals the sum, okay, or the summation. Let's not write it like that yet. We're going to write it as the summation of 1 plus 3 plus 1 plus 3 times 2 plus 1 plus 3 times 3 all the way up to 1 plus 3 times 100. Okay. I'm going to have to make it a little smaller again. Or not, I can just move it up. Okay, so now that's going to give us, now we have 100 terms, right? So we're going to have 100 times 1, that's for all of these ones. Okay, plus 3 times 1 plus 2 all the way up to 100. Okay, so it's the 100 ones here, plus the 3 times 1, 3 times 2, 3 times 3, 3 times 4, keep on going until 3 times 100. So this gives us 100 plus 3 times 100, 101 divided by 2 equals, now that's going to give us 100 times 101 divided by 2 times 3 plus 100 is 15250. Okay, let's hope I did that right the last time. Yep, I did. Last time I did use this summation notation. So you can see how it works with summation notation as well. The same sort of thing. I'm just writing it differently. The sum, n goes from 1 to 100, 1 plus 3n. Sum of 1 plus sum of 3n. And then here I do that summation. Okay? All right, I will go ahead and add this video post haste.